If we continue thinking about the domain of different functions, let's take a look at what f of x equals x cubed look like in our calculator. If I go into my y equals and I plug in x up caret 3 or x cubed and I hit graph, notice that graph is happening, I'm getting outputs on the left-hand side of the y-axis and on the right-hand side of the y-axis. That would indicate to me generally that this is going to be a domain in which I can use all real numbers. If I look in the table, I see positive numbers giving me outputs, and I also see that negative numbers give me outputs, which would indicate all real numbers. Now this makes sense because I know that I can cube just about, well not even just about, I can cube any number I want. And so the domain of f is all real numbers. And often we use the symbol, it's a double capital R, as a shortcut for all real numbers so we don't have to write it out. Now if we look at g of x, let's think about x to the 1/4. I know this is the 4th root of x. And I also know that whenever the index is even, I'm only going to be able to plug in positive numbers or 0 underneath that 4th root. I can check this on my calculator if I come back and take a look at my y equals. I'm going to take x to the 1/4 power, taking care to put parentheses around the power so that my calculator knows that all of that is the exponent. If I hit graph then, I see that I'm only getting outputs where x is positive, and if I look in the graph and calculator table, sure enough I see that negative numbers are giving me errors. So that would tell me that the domain of g is all non-negative numbers. Or recall, we could say x is greater than or equal to 0 as a shortcut there. Now, I looked at these separately because if we think about function operations, for instance, if I think of f of x plus g of x, I'm going to add those two functions together, x cubed plus x to the 1/4. Clearly, these two things are not like terms, so I can't do any simplification here. However, if I think about the domain and think about f plus g now being a function machine, any number I plug in is going to have to be able to be plugged into f and into g. For instance, if I plug in the number 1, nice and easy, kind of boring. Well, I would get 1 cubed plus 1 to the 1/4. And clearly that would give me 2. So my output here would be 2. And that works just fine because 1 is part of both of the domains. Now, if I tried to plug in, let's say, -1, I would get -1 cubed plus -1 to the 1/4. -1 cubed is -1. However, -1 to the 4th would give me an error. And I can't add an error to a number, so what I would get out here is an error. This tells me that any number I plug into f plus g has to work for both of the separate functions, which means my domain here for f plus g is only non-negative numbers, or I could say x is greater than or equal to 0. Now it gets a little trickier if we have division, let's say. Let's say I have g of x divided by f of x. Sort of adds one more level of difficulty. The reason is g of x is x to the 1/4, so we know here the domain is x is greater than or equal to 0. If I divide by x cubed in and of itself doesn't have any domain issues. However, we can't divide by 0. This means that any value that makes the denominator be 0 is going to not be a part of our domain. We're going to have to remove it. Since 0 clearly makes x cubed equal to 0, we have to remove 0 from the domain. So our domain of g divided by f is only x is greater than 0, not greater than or equal to.